Welcome back to the Instrumentation Technician channel. If you're an instrumentation technician or just beginning your journey in process control, today's topic is one you'll use every single day. We're talking about sensors versus transducers. What's the difference? Why do we use both terms in industry? And how can you easily identify them in real applications? Let's find out. 1. Understanding the basics. Let's start from the basics. In simple words, a sensor is a device that detects or senses a physical quantity, like temperature, pressure, light, or humidity, and converts it into a readable signal. For example, a temperature sensor like a thermocouple senses heat. A light sensor like an LDR senses brightness. A pressure sensor detects pressure changes. Now, a transducer is a little different. It not only senses a quantity, but also converts it into another form of energy. Usually, this means converting a physical signal into an electrical signal. For example, a piezoelectric transducer converts pressure into electrical voltage. A strain gauge transducer converts mechanical strain into an electrical signal. So, right finger a sensor detects a change. Right finger a transducer converts that change into a usable signal. 2. Real industrial analogy. Imagine you're working in a water filtration plant. You need to monitor the water pressure in the main supply line. You install a pressure sensing element. That's your sensor, it feels the pressure. But to send that information to a control room, you need a pressure transducer. It converts that pressure into an electrical signal that your PLC can read. In short, every transducer contains a sensor inside it. But not every sensor is a complete transducer. That's the golden rule. 3. Working principle. Now, let's understand how they actually work. When a sensor detects a change, it outputs a raw physical signal, maybe a change in resistance, capacitance, or voltage. But a transducer takes that raw signal and converts it into a standard format, like 4 to 20 milliamps, or 0 to 10 volts, which can be transmitted to a control system. For example, in a thermocouple, the sensor junction generates a small voltage when heated. That's the sensor part, but when that voltage is amplified and converted to a standard output, the full device becomes a temperature transducer. So we can say, sensor plus signal conditioning equals transducer. 4. Types of sensors. Depending on what physical quantity they measure. Let's go through some common ones used in instrumentation. 1. Temperature sensors. Like thermocouples, RTDs, thermistors. They detect temperature changes. 2. Pressure sensors. Diaphragm sensors, piezoelectric sensors. 3. Displacement sensors. LVDT, linear variable differential transformer. 4. Proximity sensors, inductive, capacitive, and optical sensors used for automation. 5. Level sensors, float sensors, ultrasonic sensors. Each of these sensors forms the foundation of a transducer system that converts those signals for controllers or display instruments. 5. Types of transducers. Now, let's talk about types of transducers. We can classify them in several ways. 1. Active and passive transducers. Active transducers generate their own electrical signal, like thermocouples or piezoelectric devices. Passive transducers need an external power source, like strain gauges or LVDTs. 2. Analog and digital transducers. Analog transducers produce continuous signals, like 4 to 20 mA output. Digital transducers produce discrete signals, like on/off pulses or digital code. 3. Primary and secondary transducers. The primary transducer senses the quantity directly. The secondary transducer converts it into an electrical form. For example, a board and tube acts as a primary transducer converting pressure into mechanical displacement, which is then sensed by LVDT, the secondary transducer, to produce an electrical output. 6. Key differences summary. Let's summarize the key differences between sensors and transducers. Feature: sensor, transducer. Function: detects a physical quantity, converts physical quantity into another form. Output: physical signal, electrical signal. Example: thermocouple junction, temperature transmitter. Energy conversion: not always, always converts energy. Usage: inside transducers, complete measurement system. So remember, every transducer has a sensor inside it. But a sensor, by itself, might not be a full transducer until it's equipped with conversion and conditioning circuitry. 7. Real-life examples. Let's make it practical with some real-life instrumentation examples. In a pressure transmitter, the sensing element is a strain gauge, that's the sensor. The transmitter circuitry that converts it to a 4 to 20 mA signal is the transducer. In a temperature transmitter, the thermocouple or RTD is the sensor, and the electronic converter is the transducer. In a flow meter, the orifice plate or turbine blade is the sensor, while the differential pressure cell converting it to an electrical output is the transducer. 8. Applications in industry. Now let's explore where you'll find sensors and transducers in industry. 1. Process plants. For measuring pressure, temperature, flow, and level in pipelines. 2. Automation systems. Proximity sensors detect machine part positions. 3. Robotics. Sensors guide movement and feedback. 4. HVAC systems. Temperature transducers control air conditioning loops. 5. Power plants. Vibration sensors monitor turbine safety. As an instrumentation technician, you'll be installing, calibrating, and troubleshooting these transducers regularly. 9. Signal conditioning and output 1800 to 1900. Voice. Signal conditioning is what truly separates a transducer from a basic sensor. It involves amplifying, filtering, and converting the signal into a form suitable for controllers or recorders. That's why a transducer is a complete measurement package, ready to communicate with your PLC or DCS. 10. Recap and final words. Let's quickly recap what we've learned today. A sensor detects physical change. A transducer converts that change into an electrical signal. All transducers include sensors, but not all sensors are transducers. You'll find them everywhere, from simple temperature probes to complex automation systems. Understanding this difference helps you diagnose faults faster, calibrate instruments accurately, and communicate clearly in your technical reports. If you found this video helpful, don't forget to like, share, and subscribe to our channel for more deep dives into instrumentation and process control. Until next time, keep learning, keep measuring, and keep improving.